Hello, welcome to Dev Radio. I'm here with Ajith and Srinivas Nalla, who have put together a solution to handle malicious file scanning. They work on the Microsoft Career site, which you can imagine gets quite a few files. And they used the new capabilities in Microsoft Defender for storage. And you guys are just going to walk us through what you built and what you learned, right?
Yeah, absolutely, Matthew.
Great.
Thanks for intro.
Yeah.
So let me share my screen.
Okay.
Hope you're seeing my screen.
There it is. Can you hide the little pop-up down below?
Yeah, definitely.
Thank you.
So today we are going to cover about the most important part of any application is securing their application and application servers from malicious file uploads. So the danger with malicious file uploads basically ranging from data threat as well as data stealing, and basically it also impacts intellectual property of any organization. At the end, it is a reputation damage for any organization. So malwares can range from they have a capability to bring down the entire system of an application where there is a service interruption to the users. So let me take a couple of use case examples where let me take an example of a career site. Career site might be having multiple scenarios where users come to upload their files. One of the scenario might be users updating their profile. So that ranges from resume uploads or curriculum vitae, etc. And other module might be candidates might be traveling to company location for interview process. So they might be claiming expenses incurred for the interview. So that is one more scenario. Other scenario which is common across any site is support module, where any anonymous user can access the site and then they can upload the attachments to get the support from support agents. So here it is. So there are multiple pathways where attacker can log into the system, or as an anonymous user they can upload a malicious file, and there is a high probability of system corruption. And one more typical example that we can think of is banking application, where we use day-to-day life. So we come across multiple scenarios for account opening. We may upload proof of identity documents. For loan processing, we may upload income proof documents. In the similar way, there might be a support module. So you can see the magnitude of file uploads, which ranges from one application to other application. So by using to overcome the malicious file uploads, we have a solution by using Microsoft Defender for storage in Azure. So it is an add-on service in Azure storage service, so which customers can enable for securing their application environments. So basically, what does Microsoft Defender for storage in Azure offers? It is basically a SaaS-based service where it protects users from malicious file uploads. The file uploads, it has a capability to detect polymorphic as well as metamorphic malwares. So which is a wide range of malwares that are circulated nowadays. Since it is a SaaS-based service, any new threats which are coming every day, so the SaaS service will update it regularly. So there is no manual intervention of updating the patches as compared to on-premise security solutions.
Nice. That makes a big difference. Yeah.
So coming to how we can consume the file scan status using Microsoft Defender for storage, there are two ways the consumers can consume the scan status. One is through Azure Blob Storage file index tags. One other, there is an extension by using Event Grid, where if we configure scan status will be available via Azure Event Grid Hub's subscriptions. So Initially we have used blob index based consuming the file scan status through blob index tags, wherein we explored the challenges by doing that thing. The main challenges we observed was, since ours is a UI application, uh, file scan status has to be continuously pulled through UI application for the presence of file malware scan status. So which is like not a good experience for the users, because user has to wait till the blob index tag is available, and it is also a resource intensive operation to the storage account. And one more challenge is, we have a capability where we need to display download and delete buttons once the file is successfully uploaded to the destination container. So to display this metadata information accurately once the file upload is successful, again we need to continuously poll to the blob index tag, and also upon available of the status we need to call our metadata APIs to display these links, which is like not very intuitive and not real time. So to overcome these challenges, we have come up with a push-based architecture where we can, once as soon as the file scan status is available, scan status is available to the UA application in a very real time, and also based on that we can even call the partner APIs accurately without any much delay to the user. And one more problem that we are trying to solve by following one of the architectural patterns suggested by Defender team was by using a single storage container as a entry point for any file that is entering into the application modules. For example, an application might be having multiple scenarios. Let's assume each scenario might be having their own storage account. So enabling a file scan Defender for storage on every storage account might incur extra cost. And even developers might be having direct access to those storage accounts. There might be a possibility that developers might be accessing malware files during the support process. So to address these things, we have a generic architectural pattern where file uploads will only happen through a centralized container known as demilitarized zone storage account container, where access is highly restricted. You can see the architectural pattern here. So let me explain the flow in detail. So let's assume this is a user browser where user is accessing any web application. So there are multiple scenarios where user might be interested in for a particular application. So the file upload will happen to the DMZ container. Before uploading file to DMZ container, so what we'll be doing is we'll be establishing a connection to Azure SignalR Hub. To give you some information about Azure SignalR Hub, Azure SignalR Hub is a push-based service where the real-time updates to the client application will be handled by this centralized service. So mainly Azure SignalR underlying uses supported protocol in the client system. Basically, it might be WebSockets or server-sent events based on the compatibility. So before the file upload process, we'll be client application will be communicating to Azure SignalR negotiate function. SignalR negotiate function's responsibility is to get the access token for the user. It is a short-lived access token, which can be used by the client system to have a passive communication with the Azure SignalR Hub. So once a file is uploaded to the DMZ container where Microsoft Defender for storage scanning is enabled here. So once file is uploaded, Defender service takes the file and it checks for the presence of malware. So once the file scan status is available, so it will be sent to the event grid hub, which has been configured under this Defender for storage settings in the storage container. So here we have implemented one generic component where it is subscribed to event hub events, which is published by Defender. So the responsibility of this file checker function is to take the file from DMZ container, and it checks the status of the file scan based on the event grid message information. If the file scan status is non-malicious, it moves the file from DMZ container to feature specific container. Let's assume if a file scan status is malicious. In that case, the status is sent to the Azure Signaler Hub, and the file is deleted from the DMZ container. So here the key part as part of this generic file checker function is we are maintaining this configuration in Azure app configuration, where let's say n number of features movement to their particular feature level container is handled by simple configuration information which is provided through Azure app configuration. So once the file is moved to a specific feature level container, so it is a responsibility of a particular consuming application to implement their own scenario specific implementation by using some middleware Azure functions. It might be moving file from feature specific container to their own destination database or their own external systems. So it is up to consumer how they want to implement once the file is available in their scenario specific container. So here we are suggesting one more architectural pattern where once the file is moved to destination server, consumers has the flexibility to send upload status to the Signaler Hub, so that they can call metadata APIs very accurately once the data is available in the destination servers. So this is a flexibility they will be getting. So here you can see first entry point where we are pushing event is the file scan status through our generic file checker function. Second, there is a possibility where consumer can push their own statuses to the Azure Signaler Hub once the file is uploaded to destination server, if they need added requirement. So if there is any specific message like scan status or upload status for the particular user uploaded file, so it will be listened in a push-based manner by the connected client. So it will be sent to the client in a very efficiently, so that once the scan status or upload status is available, the specific action might can be taken at the UI web application. Optionally, consumers can even subscribe logic app endpoints to perform their day-to-day administrative activities, like if they want to move malicious files to some other secure container like quarantine container for security and analyst analysis, they can even do that. So there are some predefined templates available in Microsoft Docs. They can even use this by using Azure Event Grid Hubs that we provision. Let me quickly demo the solution, how this works in real time. So you can see this is a demo application which we have created for demonstrating the file scan status, how it will be communicated to the connected client by using the generic architecture that we have provided. So let me inspect so that you can see real-time network calls for better understanding. So as a scenario one, I'll be taking non-malicious file. So you will be seeing file upload is successful, which means file is non-malicious. So you could see now the file upload is successful, which means file has passed the checks and it is non-malicious. So let me explain the process through the network calls for better understanding. First, we are initiating a call to Azure negotiate function, its responsibility is to get the Azure Signaler Hub's connection information with an access token in a secured way. And once we get this information, we'll be connecting to client will be connecting to Azure Signaler Hub, and it waits for the message from Azure Signaler Hub. Once the middleware function, which we are talking, file checker function, once the file scan status is available, it will push a message to Azure Signaler Hub. So you can see here, this is a message that this is a file I have uploaded. So I have received this message from the Azure Signaler Hub. So by using this event message name and the event handler that I code in my UI application, I'm basically displaying this success banner. So this is how it works. It is like a push-based architecture. We are not continuously polling. It is basically a passive communication with the Azure Signaler Hub, and it basically sends a message to the connected client. Let me take other scenario where I will be uploading a malicious file.
Yeah, this is the fun one.
Sorry, Matthew?
This is the fun scenario.
Exactly. So for demonstration, we have taken a test file. So it is not a real malicious file. This kind of files will be used for security analysts for demonstrating the capabilities. So we are following the same approach. So this is a malicious file for demonstration we are using. So you can see now the connection is established to Azure Signaler Hub, and then it is waiting for the events. So I think you can see the file scan status is available very fast. So the file upload is failed due to the presence of malicious content. So these kind of real-time notifications can be shown to the consumer without application refresh or continuously polling the storage accounts. So this is a benefit we will be getting by following the architecture, and it is even extensible for many scenarios. So you can see this is the message we have received from Azure Signaler Hub once the file scan status is available.
Very much a real world scenario, not hello world. That's good stuff. Thank you.
It's really useful for the loan application processing, especially.
Oh yeah.
Yeah.
And Matthew, these are the generic components we are having. So all these links are provided here, and so basically we are having bicep infra files where an entire architecture demonstrated in this architectural diagram will be provisioned within seconds if consumer utilizes this script. And we even have Azure negotiate Azure function. It is a serverless function, and consumers can utilize this to deploy in their environments. And one of the coolest part is we have a Signaler wrapper npm package which can be consumed from UI application. So the responsibility of this npm wrapper package is to establish a connection with Azure Signaler service in a secured way. And if consumers need more added protection, they can even implement their own authorization logic in the negotiate function. And also consumers can register their event listeners through the configuration properties that we expose via this npm package. So we have like two flavors of methodologies in this package. One is like component based approach where consumer can simply call the our Signaler React component, Signaler wrapper React component, and they can just pass few required parameters as a properties. This specific component takes care of connection establishment, connection starting on particular Signaler hub, as well as connection termination once the component gets unmounted. When the calling component gets unmounted, if consumers use a component-based approach, it will automatically close the connection. It provides added benefit of automatic handling of these key scenarios. One more approach is we are even exposing different wrapper methods where connection handling, connection starting, and connection termination is under the control of consumers. So they can call these methods wherever they are. It is required in different React JavaScript components, front-end components. So it is up to the consumer how they want to consume it. So one of the notation that we are following during the file upload process for the particular scenario is so client has to developer has to upload the file by following this notation. For example, the here identifier is the unique identifier related to particular user session, or it can be a unique identifier for the user. And the attachment type is nothing but the feature name and file name dot extension. So based on this, basically based on this format, we are identifying the container information where the file has to be moved once the files can status is available. So, and based on this notation, we are even listening events at the client side. Let's say if user is uploading multiple files, to accurately display particular status at the particular file, we are mapping by using this notation: identifier underscore scenario name and the file name. So it has very broad scenarios. It's up to the consumers how they want to leverage this. Yeah, and we have the Azure generic file status checker here, and we already discussed about this. Yeah. So coming to the impact that this solution pattern provides is, so if a consumer wants to develop this from scratch, it takes them at least 2 months of developer effort. So entire effort is reduced to less than 1 day. In infra provisioning and then code deployment and consuming the statuses at the UI layer. So entire solution can be consumed within less than 1 day, within even hours. So the value proposition, it gets to the internal and external stakeholders. It's like a broader range, and it can cover broader range of scenarios. And we are leveraging different strengths of Azure services to yeah, that's all from my side.
Yeah, this is great that you guys are sharing with this with the community. This is exciting.
Thank you.
Yeah. Thank you, Srinivas. And let me share my screen.
Okay.
So far the Srinivas has explained us how this Microsoft Defender we implemented, but the backbone of this system is the backend. So what are the resources that we deployed and how we are going to deploy those resources into the Azure portal. So that's the part I'm going to cover it now. We are deploying by using bicep file, this all Azure resources, which will be deployed within the 5 minutes. These all resources will be deployed into the Azure portal. What are the required for this application? So bicep is nothing but it is a domain specific language, which is similar to the ARM templates. Like whatever the resources that we want to deploy into the Azure portal, same thing by using ARM, how we are deploying, by using bicep file also we can deploy. And we can see this all resources in this Git repository. If you go to navigate to this repository, right here, we can see the lab resource deployments document. We can see how we can deploy these all resources. And coming to the each file of this, there are mainly two files. One is common bicep, one is malware scanner bicep. Why we created two files means the common bicep file is the file where we have a common resources that is used by across multiple applications. In this part, by using common bicep, we are generating app configuration, Key Vault, Lag Analytic Workspace. These are the 3 resources we are deploying. Now, whenever we are deploying these resources, we have to give resource names. So that part, if you see app configuration name, every time, every project may not have the same name. If you want to update the resource name, so this is the path, feature name we need to update. For example, we are going to use this application for loan application or resume upload or any other application, you can mention that feature name. So that this bicep file will take care. It will generate the resource name like this: loan application hyphen common configuration. And whenever we are giving a name, we need to be more cautious regarding the naming rules. So you can find the app configuration naming rules under this link. If you go to below, same thing. Key Vault will also have the same naming conventions that we need to follow. And this also have the length constant. Whenever you give the feature name, it will consider that feature name whenever you are deploying the respective environment. If you see this, this is the feature name. We are appending it. And through a bicep file, we are generating finally, this is the Key Vault name. And this DFN will change it to the feature name, if whether it is a loan application or resume. And same thing with log analytic workspace. To deploy this common bicep file, the prerequisite is Azure CLI should be installed in our system. We can install by using CI/CD pipeline also. We can implement CI/CD pipeline, but even you can install by using local machine by using these commands. Whenever you have the Azure CLI, you have to log in into the respective tenant where you want to execute these commands. Once you log in into the tenant, this is the command which we will use to execute the bicep file. If you see, I'm executing first common resources. And here, whenever we execute common resource, we need to pass the parameter file, which the parameter will have the all the values that resource is required. If you see, whenever I execute this command, I can see these 3 resources. One is the Key Vault, one is the log analytic workspace, and last one is the app configuration. This app configuration and Key Vaults are key resources which are used by the Azure function. Now coming to the malware scanner. So this is the main resource provider. If you see, by using this malware scanner, we are going to have Signaler and Azure function app. Whenever we execute this malware scanner, there is some prerequisite again. We have to configure in malware scanner parameter file with the app config as well as the common log analytic workspace and Key Vault name. These parameter values should be updated what we given in the evoke script. If you see here, we have provided this Key Vault name and log analytic workspace, right? That value we have to provide under this malware scanner parameter file, so that this scanner will pick those value. And whenever we execute this malware scanner script, while executing, it will generate this all files resources. For example, Azure resource, Azure function app, and signaler and storage account. But at the same time, we are updating the configuration value by using bicep file itself. We given a 0 configuration, so that with bicep file itself, all configuration value will be created, and the secret values will be stored in the Key Vault, and the configurations will be stored in the configuration of the Azure function app. And here, if you see, there is a 2 storage accounts. One storage account for the function app published files, one storage account for the files which we upload into the system. And this is the path where we can change the storage account name. And we have the event grid topic. As we mentioned that whenever the defender scan the files, it will send the result. To hold those result, we need a event grid topic so that our function app will be triggered. And let's see, once we created the resource of Azure storage account, now we need to enable the Microsoft Defender for cloud. The setting is we have to navigate to the storage account. If you see here, I have navigated into the storage account, and if you see, this is enabled. the Microsoft Defender for storage is enabled. But here also we need to configure some setting to send result, scan result into the top event grid topic. If you see here, this is a setting where we configure to send a scan result. Once we configured, we have to navigate to the event grid topic to enable the subscription. If you see here, subscriber, we have to give subscriber to Azure function, and also we need to configure the endpoint so that whenever the events received by the event grid, it will trigger the Azure function app so that it will process the files and it will verify. This Azure function app will verify whether the file is malware file. If it is a malware file, it will not process further. If it is a malicious file, it will say that this file is having the malicious content. And these are the key configuration. And our system is, you can extend n number of storage accounts with n number of containers with this setting. If you observe, this is the main setting, the scanner container mapping. If you see the source block container name, where your files are going to upload, this is the source container. And what is the source container connection string you are going to give? This is also a key only. It is not going to hold the secret. The secret is held by the app configuration and destination container. After scanning the result, the scan free file where you want to move, that the container name and the destination container connection string. So like this, you can add n number and the system can handle effectively. And whenever the UI, they are going to upload the malware like files or any files, what is the SAS token limit? And this is the storage string where our main files are uploading. So this is how we are configuring and how we are deploying. And these are all the backend resources. And if you go to if you want to use ready-madely that UI package, no need to configure anything. This is about the UI package npm download, so that you can integrate with any UI application, whether it is a React, whether it is an AngularJS. Only thing is you have to run the npm command by using this, and you need to import the npm package related files, and you just add it, and your application is ready to consume our malware find scanner. This is how our resources are deployed and how we can consume our application. That's it. Yeah, Matthew.
So that was about 2 months of work, huh?
Yeah. That basic file will be executed within 5 minutes. You
Great.
can assume that much speed.
When you guys were putting this together, what was the most like interesting part of it? What was as you were working through all this, what did you learn?
So when we worked with the product team, this Microsoft Defender, when they are coming into the market, we collaborated with them and we identified so many of issues, like what type of malwares can happen, how the attacker can attack the system.
Yeah.
You can assume. So not only the file, inside the file, they can even inject the file name also. These type of scenarios, we verified it.
Yeah, interesting. Well, it's awesome that you guys have shared this with the community. The links to the repo will be in the description. And thanks again, and look forward to having you on next time you build something cool.
Yeah, thank you, Matt.
Thank you.
Yeah.
Great meeting. Yeah.